In mathematics, especially in elementary arithmetic, division is an arithmetic operation. Specifically, if b times c equals a, written, a equals ba, c, where b is not 0, then a divided by b equals c, written, aab equals c, for instance, 6 of 3 equals 2, since 3 a, 2 equals 6, in the expression aab equals c, a is called the dividend or numerator, b the divisor or denominator, and the result c is called the quotient. Conceptually, division of integers can be viewed in either of two distinct but related ways: quotition and partition. Partitioning involves taking a set of size A and forming B groups that are equal in size. The size of each group formed, C, is the quotient of A and B. Quotition, or quotative division, involves taking a set of size A and forming groups of size B. The number of groups of this size that can be formed, C, is the quotient of A and B. Teaching division usually leads to the concept of fractions being introduced to school pupils. Unlike addition, subtraction, and multiplication, the set of all integers is not closed under division. Dividing two integers may result in a remainder. To complete the division of the remainder, the number system is extended to include fractions or rational numbers, as they are more generally called. Notation: division is often shown in algebra and science by placing the dividend over the divisor with a horizontal line, also called a vinculum or fraction bar, between them. For example, a divided by b is written. This can be read out loud as a divided by b, a by b, or a over b. A way to express division all on one line is to write the dividend, then a slash, then the divisor, like this. This is the usual way to specify division in most computer programming languages, since it can easily be typed as a simple sequence of ASCII characters. Some mathematical software, such as GNU Octave, allows the operands to be written in the reverse order by using the backslash as the division operator. A typographical variation halfway between these two forms uses a solidus but elevates the dividend, and lowers the divisor, or b. Any of these forms can be used to display a fraction. A fraction is a division expression where both dividend and divisor are integers, and there is no implication that the division must be evaluated further. A second way to show division is to use the obolus, common in arithmetic, in this manner. This form is infrequent except in elementary arithmetic. ISO February 9, 800.6 states it should not be used. The obolus is also used alone to represent the division operation itself, as for instance as a label on a key of a calculator. In some non-English speaking cultures, a divided by b is written or b. This notation was introduced in 1631 by William Orchard in his Clavis Mathematicae and later popularized by Gottfried Wilhelm Leibniz. However, in English usage the colon is restricted to expressing the related concept of ratios. In elementary classes of some countries, the notation OR is used to denote a divided by b, especially when discussing long division. This notation was first introduced by Michael Stifel in Arithmetica Integra, published in 1544. Computing. Manual methods. Division is often introduced through the notion of sharing out a set of objects, for example a pile of sweets, into a number of equal portions. Distributing the object several at a time in each round of sharing to each portion leads to the idea of chunking, that is, division by repeated subtraction. More systematic and more efficient, a person who knows the multiplication tables can divide two integers using pencil and paper using the method of short division, if the divisor is simple. Long division is used for larger integer divisors. If the dividend has a fractional part, one can continue the algorithm past the ones place as far as desired. If the divisor has a fractional part, we can restate the problem by moving the decimal to the right in both numbers until the divisor has no fraction. A person can calculate division with an abacus by repeatedly placing the dividend on the abacus, and then subtracting the divisor the offset of each digit in the result, counting the number of divisions possible at each offset. A person can use logarithm tables to divide two numbers, by subtracting the two numbers' logarithms, then looking up the anti-logarithm of the result. A person can calculate division with a slide rule by aligning the divisor on the C scale with the dividend on the D scale. the quotient can be found on the D scale where it is aligned with the left index on the C scale. The user is responsible, however, for mentally keeping track of the decimal point. By computer or with computer assistance, modern computers compute division by methods that are faster than long division, see division algorithm. In modular arithmetic, some numbers have a multiplicative inverse with respect to the modulus. We can calculate division by multiplication in such a case. This approach is useful in computers that do not have a fast division instruction. Properties: division is right distributive over addition and subtraction. That means, in the same way as in multiplication, but unlike multiplication. Euclidean division. The Euclidean division is the mathematical formulation of the outcome of the usual process of division of integers. It asserts that, given two integers, a, the dividend, and b, the divisor, such that b a 0, there are unique integers q, the quotient, and r, the remainder, such that a equals bq plus a and 0 a currency r, b, where b denotes the absolute value of b. Of integers, division of integers is not closed. Apart from division by 0 being undefined, the quotient is not an integer unless the dividend is an integer multiple of the divisor. For example, 26 cannot be divided by 11 to give an integer. Such a case uses one of 5 approaches. Say that 26 cannot be divided by 11. Division becomes a partial function. Give an approximate answer as a decimal fraction or a mixed number, so all this is the approach usually taken in numerical computation. Give the answer as a fraction representing a rational number, so the result of the division of 26 by 11 is but, usually, the resulting fraction should be simplified, the result of the division of 52 by 22 is also. This simplification may be done by factoring out the greatest common divisor. Give the answer as an integer quotient and a remainder, so to make the distinction with the previous case, this division, with two integers as result, is sometimes called Euclidean division, because it is the basis of the Euclidean algorithm. Give the integer quotient as the answer, so this is sometimes called integer division. Dividing integers in a computer program requires special care. Some programming languages, such as C, treat integer division as in case 5 above, so the answer is an integer. Other languages, such as MATLAB and every computer algebra system, return a rational number as the answer, as in case 3 above. These languages also provide functions to get the results of the other cases either directly or from the result of case 3. Names and symbols used for integer division include div, slash, backslash, and a percent. Definitions vary regarding integer division. When the dividend or the divisor is negative, rounding may be toward 0 or toward AA. Rarer styles can occur. See modulo operation for the details. Divisibility rules can sometimes be used to quickly determine whether one integer divides exactly into another. Of rational numbers, the result of dividing two rational numbers is another rational number when the divisor is not 0. We may define division of two rational numbers p, q and or s by all four quantities are integers, and only p may be 0. This definition ensures that division is the inverse operation of multiplication. Of real numbers, division of two real numbers results in another real number when the divisor is not 0. It is defined such ab equals c if and only if a equals cb and ba = 0. By 0. Division of any number by 0 is undefined. This is because 0 multiplied by any finite number always results in a product of 0. Entry of such an expression into most calculators produces an error message. Of complex numbers, dividing two complex numbers results in another complex number when the divisor is not 0, defined thus. All four quantities are real numbers. R and S may not both be 0. Division for complex numbers expressed in polar form is simpler than the definition above. Again, all four quantities are real numbers. R may not be 0. Of polynomials, one can define the division operation for polynomials in one variable over a field. Then, as in the case of integers, one has a remainder. See Euclidean division of polynomials, and, for handwritten computation, polynomial long division or synthetic division. Of matrices, one can define a division operation for matrices. The usual way to do this is to define A/B equals ABA1, where bar1 denotes the inverse of B, but it is far more common to write out ABA1 explicitly to avoid confusion. Left and right division, because matrix multiplication is not commutative, one can also define a left division or so-called backslash division as A/B equals or 1B. For this to be well defined, bar1 need not exist, however or 1 does need to exist. To avoid confusion, division as defined by A/B equals ABA1 is sometimes called right division or slash division in this context. Note that with left and right division defined this way, A/BC is in general not the same as C and nor is \C the same as A/B/C, but A/BC equals /B and \C equals B/A/C. Pseudo-inverse. To avoid problems when or 1 and or bar1 do not exist, division can also be defined as multiplication with a pseudo-inverse, that is, R/B equals AB plus and A/B equals A plus B, where A plus and B plus denote the pseudo-inverse of A and B. In abstract algebras such as matrix algebras and Quotient algebras, fractions such as are typically defined as or where is presumed an invertible element. In an integral domain where such elements may not exist, division can still be performed on equations of the form or by left or right cancellation, respectively. More generally, division in the sense of cancellation can be done in any ring with the aforementioned cancellation properties. If such a ring is finite, then by an application of the pigeonhole principle, every non-zero element of the ring is invertible, so division by any non-zero element is possible in such a ring. To learn about when algebras have a division operation, refer to the page on division algebras. In particular, Bott periodicity can be used to show that any real normed division algebra must be isomorphic to either the real numbers R, the complex numbers C, the quaternions H, or the octonions O. Calculus. The derivative of the quotient of two functions is given by the quotient rule. There is no general method to integrate the quotient of two functions. See also, 400 AD Sunzi division algorithm, division by two, field, fraction, Galley division, group, inverse element, order of operations, quasigroup, repeating decimal, references. External links, division at planetmath.org. Division on a Japanese abacus selected from Abacus, Mystery of the Bead, Chinese short division techniques on a Suan pan, rules of divisibility.